everyone, today we are going to learn how to solve linear systems by graphing. So knowing how to graph a linear function is going to be very important for this lesson. And that is what our warm-up is. I would like you to please go ahead and graph y is equal to 2x minus 3 on your own. And then I want you to restart the video and we'll see how well you did. Okay, so hopefully you have a straight edge with you when you graph this. In graphing linear equations, especially in the form of y equals mx plus b, it's important that you identify your b value as -3, this is your y-intercept, and your slope is equal to 2. That's your rise over run. We're going to rise 2 and run forward 1. So my y-intercept's located at -3, and I'm going to plot that first. And to find my next point, I'm going to rise 2 and run 1. And I'm going to come up with a few points on that line by applying the slope, and I'm going to connect all of those points with a straight line. It is important for you to have your line extend the entire grid and have arrows at each end, because now that we're heading into systems, it's going to be important for you to be able to identify what your solution actually is. So making sure that your lines extend the grid is going to be important. This is our foundation. As long as you know how to graph a line, you should be pretty successful in this lesson. So our learning objective for today is for you to be able to say, I can solve a system of linear equations by graphing, and I can classify the solutions as either inconsistent, consistent, independent, and or dependent. So there's going to be, depending on your type of linear system that you're graphing, it's either going to be a combination of those terms or just one of those terms. Next, I want you to be able to say, I can apply a system of linear equations to a real-world situation or scenario. So let's talk about those vocabulary words I alluded to in the first I can statement. The first is, what is a system of two linear equations? Well, two equations with variables x and y can be written as ax plus by equals c and dx plus ey equals f. Typically, the systems that you're going to see are going to be two equations that are written in standard form. So what you see right here are standard form. Sometimes you'll see them written in y equals mx plus b form, slope-intercept form, but for the most part, you're going to see standard form. And you'll graph those systems onto you'll graph each equation individually on a grid. Your solution of the system is going to be an ordered pair that satisfies the equation. And you'll need to make sure that you check your answer to make sure that it actually does satisfy the equation and make both equations true. Now, a system of equations is where you have two independent lines that are going in their own direction, and then you're going to see that they intersect at a point. But there exists other lines that don't intersect, or lines that intersect at every single point. And that's where the words consistent, inconsistent, independent, and dependent come in. Consistent means that a system has at least one solution. So at least one solution. And an example of a consistent system is where you do see two lines intersecting, and they intersect at one point, or you'll see that you have a line on top of a line. So I'm going to use some color to identify this. I'm going to use a highlighter to show that this is a yellow line on top of a pink line on top of a yellow line, and that they are the same exact line. And both of these are considered consistent. Inconsistent is a system that has no solution. And an example is where you have parallel lines. They have no solution because there is no point of intersection. Independent means that you have a consistent system that has exactly one solution. So exactly one solution. And so independent and consistent, or consistent independent, is going to be where you have two lines intersecting at one point. Dependent means that you also have a consistent system that has infinitely many solutions. Infinitely many solutions is where you have a line on top of another line, just like I have up here with the colored picture. So you'll have consistent and independent, consistent and dependent, and simply inconsistent. Those are going to be your names. So that's what I have drawn down here. So I have two lines that are going in their own directions, and they intersect at exactly one point. That is called consistent and independent. Next, we have a line on top of a line. These lines coincide with one another, and they are considered consistent but dependent. That's because every single point they share. And finally, lines that are parallel are called inconsistent. It only has one name. So inconsistent. All right, so I'm going to give you a bunch of graphs, and your job is to graph the system and then estimate the solution. Sometimes that solution will be a whole number, sometimes it'll be a fraction. You'll need to check your solution algebraically and then classify as consistent and independent, consistent and dependent, or inconsistent depending on your graph. So let's go ahead and start with the first one. I have equation number 1 and equation number 2. And like I taught you in the very first unit, you have a choice. You can either change each equation to y equals mx plus b in graph, or you can work with their intercepts. I am going to start off by changing each to y equals mx plus b, or I can change that to, or I can work with the intercepts. Why don't I work with the intercepts? Let's go ahead and do that. Starting up with number 1, I'm going to work with the intercepts. I have 4x plus 2y is equal to 4. And working with the intercepts means that you're going to let x equal 0 for the first piece, and then I'm going to let y equal 0 for the second piece. So letting x equal 0, that means that I'm going to have my first term go away. This means 4 times 0 plus 2y equals 4. Or essentially your first term goes away. Making this 2y is equal to 4. Dividing both sides by 2, we end up with y is equal to 2. So I have the ordered pairs 0, 2. So I'm going to plot 0, 2. Next, I'm going to come up with my y-intercept. And my my x-intercept happens whenever y is equal to 0. So that means I'm going to write 4x, and I can just eliminate that 2y, and this is going to simply equal 4. Dividing both sides by 4, I find that x is equal to 1, which means that my ordered pair is going to be located at 1, 0. So I'm going to plot 1, 0. All you need are 2 points in order to graph a line, and if you want to come up with more points, you can. I can see that this is going to be a slope of -2 over 1, so I can go now -2 and over 1, down -2 over 1. I can go up 2 and to the back 1, and I can come up with as many points as I can on that line. What's helpful about that is the more points that you have, the easier it is to find your solution to the system. Cool, this is equation number 1. Next, let's go ahead and talk about equation number 2. In equation number 2, I have 2x minus 3y is equal to 10. And I'm going to identify the intercepts. So I'm going to let x equal 0, and then I'm going to let y equal 0. Letting x equal 0, I have -3y is equal to 10. And I'm going to divide both sides by -3, and I find that y is equal to negative 10/3. So I'm going to plot the ordered pair 0, negative 10/3. And negative 10/3, well, that is located at 3 can go into 10 3 times with 1 left over. So this really is like negative 3 1/3. So what you're going to do is you're going to approximate where that's located. Okay. So I'm going to go to where 0 and then negative 3 1/3 is. So 1, 2, 3, and just a little bit. Next, I'm going to identify my my x-intercept by letting y equal 0. So I'm going to go 2x is equal to 10, and I'm going to divide both sides by 2, and I find that x is equal to 5. So I'm going to plot the ordered pair 5, 0. So I'm going to go over 1, 2, 3, 4, 5, and I'm going to plot 5, 0. Now you only need 2 points in order to graph a line, and now that I've plotted all of the points that I can pretty much see where the point of intersection is going to be. And it appears as if the point of intersection is going to be located right here. And that ordered pair is located at 2, negative 2. So now we have to check our solution. We plug 2, negative 2 back into both equations. So I'm going to have to plug in both equations. So here's my check step. I'm going to be checking 2, negative 2 back into both originals. So working with number 1, I need to show that 4 times 2 plus 2 times negative 2 is equal to 4. This is equal to 8 minus 4 equals 4. Cool. Let me check my other equation. In my other equation, I'm going to have 2 times 2 minus 3 times negative 2. Does that equal 10? So is 4 plus 6 equal to 10? Yes, it is. Cool. I've just shown that 2, negative 2 is our solution. And because of that, because we have only one solution, this means that our system is consistent because it actually has a solution, and independent. So this is called consistent and independent. Okay, let's go ahead and flip to the next page. And let's go ahead and graph this next system for letter B. For letter B, we have 4x plus y is equal to negative 2, and negative 6x minus 3y is equal to 12. So the first thing I'm going to do is label each equation, and I'm going to work with each equation by identifying their intercepts. Or I can work with y equals mx plus b. So I'm going to show you what y equals mx plus b actually looks like for this one. So looking at number 1, I have 4x plus y is equal to negative 2. I'm going to subtract 4x on both sides, and I end up with y is equal to negative 4x minus 2. All right, my slope is equal to negative 4. My b value is negative 2. And I'm going to plot or graph this line. So I'm going down to negative 2, and I'm going to go down 4 and to the right 1. I'm going to see if I can come up with another point by rising 4 and going over 1. Like I said, it's always helpful to come up with as many points as you can on a graph. Awesome, and here's my first equation, or my first graph. This is number 1. Number 2, I have negative 6x minus 3y is equal to 12, and I'm going to solve for y by adding 6x to both sides. I end up with negative 3y is equal to 6x plus 12, and I'm going to divide everything by negative 3. And by doing that, I end up with y is equal to negative 2x minus 4. Okay, let me go ahead and graph this. My y-intercept is located at negative 4, and then my slope is negative 2. So I'm going to go down to -4, and then I'm going to go down 2 and to the right 1, and down 2 to the right 1, and I'll come up with a few more points on this line. And I can already tell what my solution is going to be right away. It's located right here, and that is located at 1, 2, 3, 4, 5, 6. 1, -6. That's our solution. So now what I need to do is I need to figure out or verify that this solution is actually our solution. So this is where my check step comes in. So my check step, I'm going to check number 1. I'm going to check the ordered pair 1, -6, and I have 4 times 1 plus -6. Is that equal to -2? Is 4 minus 6 equal to -2? Why, yes, it is. In equation number 2, I have -6 times 1 minus 3 times -6. Does that equal 12? Yes, -6 plus 18 does indeed equal 12. So I've just shown that it works for both. And do you have to show the check step? Yes, you do. And because it works for both, I can now classify this as consistent because it has a solution, and independent because it has only one solution. Let's go ahead and look at letter C and letter D. For letter C, I'm going to label each equation 1 and 2. And every time that you start these problems, you have a choice. You can either work with y equals mx plus b, or you can work with the intercepts. I'm going to go with y equals mx plus b again. And here we go. So I have number 1, -2x plus y is equal to 4. I'm going to add 2x to both sides, and I end up with y is equal to 2x plus 4. So I'm going to go up to 4, and then I'm going to rise 2. I can't rise 2. Instead, I have to apply the slope backwards. So I'm going to go down 2 and to the left 1, down 2 and to the left 1. And I still have a slope that's going to be increasing, but you just have to be careful when it comes to those types of lines. All right, here's my first graph. Next, number 2. I have 4x minus 2y is equal to -8. I'm going to subtract 4x on both sides to get y alone, and I end up with -2y is equal to -4x minus 8. Dividing every single term by -2, I end up with y is equal to 2x plus 4. So I'm going to go up to 4, and once again I have to go down 2 to the right 1, and I'm going to be plotting the exact same points. Look at these equations. These equations are these exact same equations. So what that means is that these two original equations have infinitely many solutions. There is nothing that we can truly check. So, with that being said, this is called consistent and dependent. Okay, let's go ahead and look at letter D. For letter D, we're going to solve the system. So I'm going to solve the system, and I'm going to label each equation 1 and 2. And I'm going to write -2x plus 4y is equal to 8. And I'm going to solve for y again. Like I said, you have your choice. You can either solve for y or you can work with the intercepts. I'm going to add 2x to each term, and I end up with 4y is equal to 2x plus 8. I'm going to divide every single term by 4, and I end up with y is equal to 1/2 x plus 2. So I'm going to go over to 2. That's my y-intercept, and I'm going to rise 1 and run forward 2 and come up with as many points as I can on this line. And draw my line. And here's equation number 2. I have negative 2x plus 4y is equal to negative 4. I'm going to solve for y by adding 2x to both sides. And I end up with 4y is equal to 2x minus 4. And dividing every single term by 4, we end up with y is equal to 1/2 x minus 1. So I'm going to go down to negative 1. And then I'm going to rise 1 and run forward 2. And come up with as many points as I can. And this time, we have two lines that do not intersect with each other. They're parallel. So that means that there is no solution. But we can still classify no solutions. They are called inconsistent. So on your homework, you're going to be required to graph functions on actual graph paper. So please make sure that you grab some graph paper in my classroom and actually graph these functions and show where those points of intersection actually are. And then after you have those points of intersection, if you end up coming up with a point, you've got to prove that it actually works for both. And then we call it consistent and independent, consistent and dependent, or inconsistent. Let's go ahead and look at our final problem, our final example. And in this story problem, it says, at an ice cream shop, one pays $9 for 2 sundaes and 2 milkshakes. A second customer pays $13 for 2 sundaes and 4 milkshakes. How much does each sundae and milkshake cost? Solve by graphing. Okay, before we do anything, we need to establish what our variables are going to be. And typically your last statement will tell you what your unknowns are. We need to know how much does a sundae and a milkshake cost. So I'm going to let x equal the cost of a sundae. And I'm going to let y equal the cost of a milkshake. This is always step number 1. Always label what your variables are. So x is going to be the cost of a sundae and y is going to be the cost of a milkshake. Next, you need to set up your equations. So at an ice cream shop, one pays $9 for 2 sundaes and 2 milkshakes. This information represents your first equation. So if you pay for 2 sundaes, 2 times x, plus 2 milkshakes, 2 times y, you will pay $9. The second statement, where you have 13 is equal to 2 sundaes and 4 milkshakes, is your second equation. 2x plus 4y is going to be equal to 13. And that's your system. So this is the second thing that you do. And now we need to graph our system. So we can work with the intercepts, or we can solve for y equals mx plus b. Because I haven't really done the intercepts, I'm going to do the intercepts for you guys. So I'm going to call this equation number 1, and we'll call this equation number 2 down here. And working with equation number 1, I have 2x plus 2y is equal to 9. And I'm going to work with my intercepts, and I'm going to let x equal 0, and that means that I'll have 2y is equal to 9, dividing both sides by 2. We have y is equal to 4.5. So my ordered pair is going to be located at 0, 4.5. So I'll go over to 0 and up to 4.5. Then I'm going to let y equal 0. So I have 2x is equal to 9, dividing both sides by 2. Once again, x is equal to 4.5. So I have 4.5, comma, 0. And now plot where 4.5 is. And I'm going to draw a segment, not a line, because it wouldn't make very much sense for our values to go into negative territory. Next, I'm going to work with equation number 2. That is 2x plus 4y is equal to 13. And I'm going to work with the intercepts. I'm going to let x equal 0. So that means that I have 4y is equal to 13. Dividing both sides by 4, I find that y is equal to 3.25. So I'm going to approximate where 0, 3.25 is located. It's going to be closer to 3, but not quite halfway. And now I'm going to let y equal 0, and I'm going to find x. So I'm going to write 2x is equal to 13. And dividing both sides by 2, I find that x is equal to 6.5. So I'm going to plot the ordered pair 6.5, comma 0. And now I'm going to connect. And now we've got to kind of figure out where is the point of intersection. And this is why graphing is not considered the best approach, because it's really tough to tell if you're not accurate with how you graph, if you're off by just a little. It's challenging. And in this case, the point of intersection is located at 2.5, comma 2. It's tough to tell that, but that's what it is, 2.5, comma 2. And what this represents is it represents that a sundae costs $2.50. And it represents that a milkshake costs $2. And that is it. Ladies and gentlemen, this is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.